Welcome to this episode. For me, this is a very special episode because this is being filmed with somebody that I really respect in the application security industry, so to speak. The person I'm talking about is a leader in the software bill of materials and the source composition analysis space. Not only does he have an extensive amount of experience in this place, he's also built some extremely world-class tools and open source tools at that to support and nurture this space. With me, I have Mr. Steve Springett. So welcome, Steve. Welcome to the podcast. I'm glad to have you here.
Thanks for having me. I appreciate it. Always glad to catch up with you.
Thanks so much. So, Steve, before we get started, I always ask all of my guests this question. How did you get your start in security? And what kind of brought you to security? Because a lot of times people don't start in security. So just tell us your origin story, Marvel style.
Yeah, I actually got into physical security before I was actually in information security. I was doing access control systems for banks and high rises here in the city of Chicago. And it wasn't until I started doing some really early web development, like 94 or so, that up and through that 2000 era, that organizations actually started bringing in security into their vocabulary. And I was responsible for putting some of the first airline reservations on the internet. That's long time ago. But it wasn't until around 2008 or so where I was working for a French software company out in Scottsdale, Arizona. And I was hired for this whole pharmaceutical supply chain thing where you were tracking raw materials up through the manufacturing process, wholesale distribution, up to your pharmacy shelves, that entire supply chain, which there were so many really fascinating use cases. That's where I really started to get into security. I started doing static analysis, started with Fortify version 2.5, I think, and have been, using Fortify ever since. But that's really where I kind of got hooked on the whole supply chain thing, just because it's such a fascinating, it's just a big market. There's not just one thing to concentrate on. It's very big picture.
Right. So one of the first questions that I want to ask you, and I think you're the best person to answer this question. What does supply chain security mean to you? Because we've seen this word being bandied about quite a bit, right? We've had these massive breaches that everybody talks about that are supply chain based. We had SolarWinds that are supply chain based. Everybody talks about supply chain quite extensively. What do you define as supply chain? And what do you mean by software supply chains, so to speak?
Yeah, I look at software supply chain as it's kind of like the macro. It's looking at, if you look at SCA solves a very small, very specific problem, and it's very reactionary in the way that it solves it. So it's not a strategic type of thing that most organizations should actually start with. But when you step out, a good 10,000 feet, you're not only looking at the libraries and stuff that you're pulling in and all the contributors to those libraries, but you're looking at other things. You're looking at SDKs, you're looking at compilers and compiler flags. You're looking at repositories and version control systems, which are all inherently broken. You're looking at build servers, and if you have a CD pipeline, you're looking at how you distribute that and where you distribute that, and then how those artifacts are then retrieved. So you're taking a much further step back with a much wider lens and looking at the more holistic, how everything actually communicates. And the interesting thing about that is that when you start looking at everything that could potentially go wrong, you quickly realize there's not one or two or three different products that you can just slap in here and say, I have a secure software supply chain. It's not the way it works. In fact, I would argue that it's impossible to deploy any kind of product to solve this. It's really, I look at software supply chain as really a truly cross-functional requirement that every business, every organization needs to kind of adopt. So it's more about processes and teams, internal teams working together to identify areas of risk, whether that risk is coming from internally, whether it's coming from your suppliers, your business partners, even your customers in some cases. So it's really this whole cross-functional thing with a very big lens and looking at a lot of different types of problems. And you can go into rabbit holes in each one of these little domains, but it's fascinating the amount of things that are inherently broken, which is why I think software supply chain is going to be, such a hot topic for the foreseeable future.
Right. That was very interesting. There are a couple of points that I want to kind of deep dive into from what you said there. First of all, when you spoke about products, and I think a lot of products are going to be a little cheesed off by what you just said, which is, hey, you know what, I can't use products to solve this. What do you mean by that specifically? And when I ask you that question, what I mean is that how would a company go about starting off doing this process well? What would be your definition of doing this well? How would I start doing this well? And where should I go after I start doing this well? What's I hate to use this term, but unfortunately that comes up, the maturity model journey of this sort of thing for that companies can start looking at from a supply chain perspective?
That's a really big question, but the OAuth software component verification standard attempts to address this. It's a joint effort. Myself was part of it. I had a co-author from Fujitsu subsidiary, as well as another co-author that pretty much does just national security type of things. And we came up with the OWASP SCVS standard, which is really interesting because it tries to focus on a lot of automation. So I don't think whatever, as organizations do, I think whatever they end up doing needs to be automatable, right? You can't have any kind of success in any kind of manual process. It's just not going to work, especially as our supply chains get much larger and much more complex. But first is just knowing what you have, inventory. And surprisingly, that's a very hard problem to solve. If you look at all the SCA vendors, for example, and you actually do an evaluation in terms of not what the vulnerabilities they find, that part is actually easy. When you're actually trying to identify the thing in the first place, SCA tools are not designed to identify an accurate inventory. They're designed to identify risk. And in most cases, being close enough is good enough. So if I'm off a couple versions on this one component because of XYZ, well, that's okay because that component still has this vulnerability. So I'm okay. But that's not okay when you're looking at the much larger picture. You actually have to know what exactly you have, including all the modifications thereof. So open source is the ultimate supply chain, and organizations will fork things and modify things and redistribute things and repurpose things and repackage things. And it's really up to us to kind of figure out what all those modifications were, because is it just that modified thing now, or have I created something new? And in many cases, you're actually creating something new, and that then goes out in the market, and that thing that it was originally derived from also is part of that risk. And now the world doesn't know that. So actually knowing what you have is truly a hard problem to solve. But before then, you kind of have to lock down your build systems. If you're using any kind of build system out of the box, you're doing it wrong. I remember spending about 2 years just locking down Maven. Take Maven. It took us an organization 2 years just to lock down Maven so that we actually had repeatable builds, so that we knew when we actually put software through a pipeline, what you actually get out at the end is actually what you expected to get out at the end, right? And that means, hardening your CI servers, because those, especially the on-premise ones, are just inherently insecure. In fact, most development tools are inherently insecure just because they're designed to get developers productive quickly. right? That's where the focus is. They're not designed to get developers productive quickly and securely. That's not necessarily what the tools are designed to do. So we have to lock down build servers. We have to lock down SDKs and all the configuration files on developer machines. And we have to lock down DNS and internal repositories and all kinds of other things just to be able to have some kind of confidence at the end. What we think we're actually building is what we actually get. And that's a really hard problem to solve. And most organizations that I've ever, talked with, they don't actually go to that extra length. And when you don't go to that extra length, that's where supply chain things actually start to bite you, right? You pull things from your internal repository, thinking that you're the only ones actually writing to that repository, and then boom, now you've got a backdoor in whatever it is that you're distributing, and now you're compromised to potentially millions of people.
Now, I'm going to kind of hone in on a couple of points that you've mentioned here, especially focused on inventory. So from what I understand, and pardon me if I'm making a few gaffes here, it may be obvious to someone like you. One of the points that I think of when I think about inventory and source composition analysis is that inventory is software bill of materials, and source composition analysis is the study of vulnerabilities of your inventory. So is that, first of all, correct? And if yes, what have you done to sort out these two issues? You can talk about your project specifically and how your project specifically have addressed these issues, because I know you have definitely done things in these two spaces. How you've addressed them, what you've essentially focused in on, what were your goals while trying to address these two possibly even disparate issues, right? So yeah, let's...
Okay, yeah. I haven't seen a definition of SCA that actually, I think that actually truly describes what the tools actually do. I like to look at the approach and how they do it. So instead of like describing SCA, we're all looking at third-party open source components. I like to step back and describe how these tools do it, because that actually makes a big difference. SCA tools, like I said earlier, are designed to identify risk, not necessarily to create that accurate inventory. And they do so by either doing binary analysis, looking at the files themselves, they'll look at the coordinates, they'll look at, maybe the file hash or maybe the AST fingerprint, whatever method of analysis they use, it's some kind of binary thing, or they look at the manifest. And in both cases, both of those are educated guesses. You're looking at something, I see evidence of this thing, therefore it is that thing. In a lot of cases, yeah, that's going to be true. But again, open source is the ultimate supply chain, and organizations will and continue to make modifications for things and change things, redistribute things, rename things, and what you think you have may not necessarily be true. So if you actually start the other way, so SCA I look as more of a reactionary type of thing where it's really easy to get the tools installed. There's a bunch of commercial vendors in the space, but don't expect a complete 100% accurate inventory from these tools. I've done my own bake-offs, so to speak, and none of them really got above 90 some odd percent in terms of their accuracy. And that's just for component identity. That's not even talking about vulnerabilities yet. But if you approach the problem from the opposite perspective, if you start asserting what that inventory is, and you actually have a portable mechanism that actually describes what that inventory is, and you put it through your pipeline, now developers can have control over what that inventory is. So if they've actually made that modification to that thing, they can actually describe that modification to that thing. Who made it, what the modifications were, what components it was derived from. So you have a much more accurate representation of reality. And if there's any kind of corrections that need to be made as well, you can add those as well. But you also, when you have that inventory, being portable now, which is really what SBOMs or software bill of materials is really about. It's a portable way to describe your inventory and and who you got things from. But when you have an SBOM in your software supply chain, now you can start adding more full stack things. If I'm producing a Docker container, well, I can describe the libraries and applications and OS packages and the operating system that is in that container. If I am also distributing an IoT device, or if I'm distributing a medical device, I can describe that entire stack. And in many cases, if I'm describing an automobile, it's going to have multiple software stacks. I can describe all of them. So it tries to address, I guess, a much wider picture once you actually start doing an inventory first approach rather than an inventory last approach, which is currently what most SCA tools do today.
So one of the things that, of course, that you have been working on, and I see a lot more traction to this that has happened over the last couple of years, because I've been following your work on GitHub and other forum, is CycloneDX, right? So CycloneDX is your software bill of material standard that you've created. And you've obviously, it's open source, it's available for people to use. Now, could you talk a little bit about CycloneDX, how it started, how it's going, what do you see as the future for that project? Because I think that for me is, let me explain where I'm coming from on this, because the way I see it, a lot of people, it seems extremely important as I listen to you now and as I talk about it with clients and people who I train. But a lot of people don't understand this concept. So what is this meant to solve? And what did you want to do with it when you started off? How is it going? And where do you see this going? So that's my next question.
I think a lot of the projects that I'm involved with, whether it's CycloneDX or like Dependency Track or whatever, I think a lot of the projects that I'm involved with in this space is really kind of a reflection of frustration, actually. There were requirements that I've had since 2013 that the industry hasn't actually addressed. We would call that a market failure. Most people weren't asking for these things, therefore the market wasn't creating them. It's one of the reasons why some of the work that Alan Friedman from the National Telecommunications and Infrastructure Administration, looking at software bill of materials, it's the reason why that group exists. But a lot of the work that I've been doing over the last decade has really been driven out of that. I have these basic requirements, and there wasn't any commercial solutions to address them. But I think to answer your question about CycloneDX specifically, CycloneDX started in 2017, and it started as just a very simple way to describe what inventory I had and what type of inventory it was. Was it an application? Was it a library? Was it a framework? Library versus framework actually has that's important information. It goes to, whether or not something is highly coupled versus, loosely. So there's some interesting things that you can do with kind of making that distinction in itself. But you have other types of components as well. But it was really just a way to, from a security first perspective, describe that inventory. There wasn't really anything in existence at the time. There was the only thing that remotely came close was SPDX from the Linux Foundation, but security wasn't really in their vocabulary. They were primarily focused on license and intellectual property use cases. So when you're looking at security is typically how you get in the door of a lot of organizations. And once you're in that door, license and all these other types of use cases, try to, clamor on. But I went first and foremost with a security first approach. And I went with an approach that was very, I guess, aligns to a lot of the automation that everyone in our space is doing, right? So that meant, instead of having the object model that was ideal, it meant having an object model that was ideal for automation, right? And you'll see some architectural decisions in CycloneDX that it has a very simple model just because we want it to be modifiable and correctable throughout your build pipeline. But CycloneDX started in 2017. It's had a couple of different revisions since then. We're currently up on version 1.2. We are planning 1.3. And we're also going to be launching here some really interesting initiatives beginning of February, I think. So the project is growing. It is now more popular than the thing it was originally created for, which was the original purpose. I just didn't know if it was going to be successful or not. But it was originally created for OWASP dependency track, but now it's supported by multiple commercial vendors. It's supported by a lot of different security tools. It's starting to be supported by CMDB and more traditional IT type of systems. And it's been referenced in a lot of different types of articles regarding software bill of materials. It's one of two viable, in my opinion, two viable standards that exist today for software bill of materials, CycloneDX being the only one with a security first approach.
One of the things with CycloneDX is that it's gotten a lot of traction with GitHub Actions, and I see a lot of folks who've written integrations for GitHub Actions. That's always heartening to see. So I definitely encourage people to check out CycloneDX. I like it a lot because I think it standardizes a lot of disparate pieces of information. One of the things that, and this is kind of segueing into my next question to you. One of the things that I've always seen with software bill of materials or subsequently with source composition analysis is that the package manager plays a big role. The package manager, the local build system, Maven, cheese shop, NPM, whatever, right? And some of them get it right. For instance, NPM gets it righter than others. I'm not saying it's perfect, but I'm sure compared to maybe the Python ecosystem, I think NPM is head and shoulders above. But what I want to know from you is how important is the packaging or the packaging ecosystem of a language or that or a particular framework or a set of frameworks, so to speak? How important is that? How is it? Is it something that is, hey, you know what? There are ways around this, and we can still solve this, or is the package manager a 60-70% influencing factor in the way we do or the quality of the inventory that we have as part of our supply chain?
Yeah, no, that's also a really interesting question, and it sounds like you've had some experience with some inaccuracies in some inventory, which can be true for sure. But package managers play a very important role in not just producing accurate software bill of materials, but in the wider supply chain conversation as a whole. And I'll talk about that in just a moment. But if you want to know with certain amount of certainty what inventory you have, starting with a package manager allows you to go from 0 to 80% really, really, really fast with minimal effort. So that is going to give you the biggest bang for your buck, is just starting with a package manager. If you're dealing with, if you're working on ecosystems like C, C++ that typically haven't used package managers, guess what? There's package managers that have been there for the past decade. There's multiple package managers for those things, for those languages. So, I'm really encouraging others to adopt them. In terms of package managers outside of just the whole SBOM thing, package managers typically also use repositories. And I'm not talking about the decentralized ones like Go and that sort of thing, which is a conversation in and of itself. But having a centralized repository is a very good thing for security. In fact, I will not use any ecosystem that doesn't have a centralized repository. It's ludicrous to even think that. If you think about buying pharmaceuticals or buying food, we always know where food or where that specific drug came from in the event that something happened in the manufacturing process that tainted whatever that was, so that we can recall it, right? We don't want people to get sick. We don't want people to die. So we actually recall those things from our software supply or from our physical supply chains. Not having that centralized repository that most package managers also rely on gives that, not having that prohibits us in many cases from recalling software components from our software supply chain, which means that others are potentially going to use this years and years and years down the road, even though we've known for the past couple of years that this thing is bad. It should have been pulled from the shelves, but because there's no central repository, we can't do it. So good luck, everyone. So having not only the package manager, but that centralized package repository, in my opinion, is really important. I know there's a lot of negative things that come with a centralized repository. There's things for governance. Many commercial entities end up supporting it. So there's possibly conflicts there. And there's all kinds of other kind of motivating factors. But I think the benefits of having that kind of ecosystem far outweigh the cons of not having that, right? I want the ability to have components recalled so that, no future projects ever use them again.
Yeah, so my next question is going to be around the future, right? So one of the things that scares me constantly, and I keep looking at this, for instance, I do a lot of serverless coding, I do a lot of Lambda stuff. We have layers, you have new ways of introducing code into your Lambdas, you have new ways of extending them. The cloud native world has kind of, taken supply chain to levels that you may not have imagined when you first got into the industry. We're looking at Kubernetes, we're looking at cloud, we're looking at, and not just one cloud, right? We have multiple clouds, we have their own sets of disparate ecosystems, their own deployment patterns. What do you make of this? And do you think first of all, what do you make of this? And second thing is, do you think we're coming to some sort of a way to address this? Because I see a lot of gaps, right? For instance, in the Kubernetes world, I don't see very kind of unified products or unified solutions to address this. Neither do I see that in the cloud world itself, right? When you're directly on the public cloud, I don't see it. Do you see, first of all, is your experience different? And where do you think this is going? Are we dealing with much more complex supply chains, which are not yet well addressed? Or are we dealing with, yes, we are dealing with complex supply chains, but there is definitely a lot of good stuff that's happening, et cetera, et cetera. So what are your thoughts on the future?
So, I guess one of the things that the SCA products in general can't address that a SBOM can is APIs. Right? What are the APIs that are also components? It's just they're serialized differently. What are the third-party APIs that my application relies on? Because that should be part of my inventory as well as what kind of data classifications are going back and forth on those APIs. Is authentication required? Does it cross the trust boundary? All that kind of information can be described today in software bill of materials, specifically CycloneDX. So I think there is some room there for a little bit of growth for the SBOM use case, but SBOMs are really used to describe the inventory of that thing. It's not necessarily designed to solve all security problems, but it does do a good job in the inventory. Regarding the overall stack thing that we are going down, I think there's going to be, I think software supply chain, just because it's constantly in the news every other month, somebody gets popped. I think there's going to eventually come a point where some of these tools start baking in a lot of security things into the tools themselves. Build tools, for example, that produce SBOMs, and build tools that describe, well, this component actually talks to these other things. Did you know it actually talked to those other things? Because these are the things that it actually talks to. So I think you're going to start seeing some integration to provide some of that visibility for us security guys. But I think we're as always, we're going to be playing catch up to what the cloud native industry is doing, which is truly unfortunate. But as we keep on going in that direction, we still have, in my opinion, the growth industry is really about embedded devices, right? And they're connected to all these things, these multi-stack cloud native things that you're describing. We have just a bunch of smaller devices. And whether that is embedded implantable medical devices inside of people, whether that's the 30 or so computers that are in your car, or that are controlling stoplights. I think the amount of devices that communicate with this multi-stack world is also, going to continue to escalate. And we actually have a lot of solutions today to address like the inventory and software supply chain things for those. Unfortunately, a lot of those smaller embedded things still rely on a lot of bad practices, a lot of legacy development type of methodologies, C and C++ without any kind of package managers, modified, libraries without necessarily any kind of provenance or pedigree in terms of what it is that those components are and where they were derived from. So there's a lot of maturity in the embedded space that I think needs to happen. But I think it's going to be really interesting because on one side, you've got all these smaller devices and the explosion of those. On the other side, you've got all the cloud things that are escalating to support all these smaller devices. And security guys are kind of in the middle, trying not to get squished. But I think, because everything is constantly in the news, there's been a lot of efforts more collaboratively between organizations to start sharing things. There's a big movement for software transparency, for example, that's led by Alan Friedman from the National Telecommunications and Infrastructure Administration. It's part of the U.S. Department of Commerce. It's a multi-stakeholder thing. It's multi-country thing. There's folks from Japan and Australia and various parts of Europe and elsewhere that are participating in these efforts. But there's other efforts going on as well, especially sector-specific efforts for like healthcare and energy and all these other types of verticals. So I think there's going to be a continuation of collaboration, knowing that a vendor or vendors is not capable of actually solving this problem. It really takes people. It takes collaboration to make any kind of improvement. So I think we're going to see a lot more of these cross-functional collaborative efforts going forward as well. That would be my hope anyway.
Slightly changing gears a little bit. I want to talk about the vulnerability. Now we've spoken about SBOM, we've spoken about inventory for a bit. When it comes to vulnerabilities itself, right? So a lot of us today see, at least I'm seeing this kind of distribution of databases, especially when it comes to vulnerabilities, right? We have the CVE, then we have Rust that's maintaining its own database. Node has always maintained its own dataset. Where do you see this going? Because we're adding a lot of languages as well. Every 2 months, there seems to be something new out there. There is Elixir, there's VLang, there is NIM. I don't even need to tell you that the language ecosystem is expanding as the needs for specialized development expand as well. What do you see? First of all, what are your thoughts on the centralization and how good the centralization of vulnerability databases are today? And where do you see this going? Where do you think we're headed towards in the near and long-term future?
Yeah, that's also a really interesting question. So the NVD, the National Vulnerability Database, hasn't been able to keep up with the volume of vulnerabilities in a very long time. There's also a lot of inaccuracies in all their data. So I can't tell you the number of times that that I've found inaccuracies in their data, and you just send an email to them and they'll correct it. But the NVD was created in a completely different time, right? I mean, the early CVEs are from the late 90s, and that was a completely different era. That was before the open source thing kind of exploded. That was obviously way before the cloud and all that sort of thing was ever a thing. So, as a result, a lot of their processes that are used to identify what software is inherently flawed. It doesn't actually scale, and it doesn't meet the needs of open source today, let alone in the future. So the NVD, for example, relies on this thing called a CPE, or Common Platform Enumeration. It's a way to describe what it is, who the vendor is what the name of the application is and what the version of that application is. And there's some other things you can do in there as well. But those are the three primarily fields. That actually are all human created fields. So none of those fields are actually created through automation. I like to use JBoss as a really good example. JBoss for the Java or for the non-Java folks is a bunch of libraries and server type functionality in the Java ecosystem. The project identifies itself as org.jboss and then whatever the component name is. In the NVD, it's identified as the vendor being Red Hat. So if you're relying on automation, guess what? There's three fields, and all three fields are going to be inaccurate for most JBoss components. You can't scale vulnerabilities identification if the system that you're relying on does not use the naming conventions that are native to that particular ecosystem. So CPE was a way to originally describe, like I said, vendor name version of mostly commercial software. And I think it's still viable in many cases to be used that way. Although they are looking to change over to SWID or software ID tags, we're still kind of at the community, we're still waiting. That should have been announced last year, but they're still trying to figure it out. But I think because they're still not focusing on how components are actually named in the real world, that's kind of your clue that the relevance of the NVD is going to continue to diminish over time. I predict that, I think in order for you to have an accurate and scalable vulnerability intelligence system or platform, you actually have to describe components in however native ecosystems, whatever the native ecosystem that the component is from. So if you're describing Maven, you should be able to describe, via coordinates or via package URL, for example. Having, a Maven component be represented as a CPE just doesn't make sense because those projects don't use CPEs. So now you actually have to have a human being in there to actually make that correlation. It's just not sustainable. So I think you're going to see the continued erosion of the NVD in terms of its relevance going forward. And I think decentralized vulnerability intelligence is going to be the new norm. It's not going to be a norm that many security people want to see happen, but I think it's inevitable. You have GitHub advisories, you've got Friends of PHP, you've got, the stuff that OSS Index from Sonatype is doing, you've got commercial sources like risk-based security. You've got a lot of really good sources of vulnerability intelligence, and many of these sources have a lot of vulnerabilities that are not in the NVD today. So, I would beg the question, if you're not looking at commercial vulnerabilities in commercial software and you're using just for like open source things, the NVD probably shouldn't be your first choice.
So I just thought we'll have one last question from you and before we head out. So of course we're filming this in the new year 2021, and last year has obviously been eventful for all of us on the planet. What are you looking forward to in 2021? What are you doing? What are your next big things that you're going for in 2021, and what are you planning to do? What can we expect from you this year?
Well, in my open source life, I'm doing some really interesting things. There's some things that I'm working for dependency track that's going to be exciting. I'm experimenting with a bunch of things that approaches to solving problems that have never been done before. Much like version 3.x of dependency track was one big experiment. Can SBOM be both complementary and competitive to SCA tools? The answer was yes and yes. There's a lot of things in dependency track version, the 4.x series, that are also kind of going to be experimental, right? Because nobody's done this before. So I'm looking forward to kind of that kind of research projects and putting that out into the marketplace and just measuring the results, right? Getting the feedback. I think it's going to be really interesting. the CycloneDX project, there's going to be some really awesome things that we're going to be announcing here shortly, and into this year that's really going to be interesting. I think you're going to see a lot more already we've kind of the adoption has just exploded. It's like I said, it's more popular than the project it was originally created for. It's absolutely fantastic. It's truly a blessing to have something that you've created with a very specific purpose being used for all different kinds of things, especially like these safety critical life-saving things that you just never envisioned, something being used for. So it's kind of humbling to see that. But we're going to be doing some really interesting things with CycloneDX this year that I'm really looking forward to. But this is a new year, and I'm really interested. I'm really looking forward to once the snow melts, going outside and playing with my daughter some more. We didn't go to any kind of parks last year because of COVID, so we moved into a new place. So I'm really looking forward to kind of, I guess, a new way of life this year. Hopefully it's a kind of a renewed start for a lot of things. So, those are the things that I'm looking forward to.
Absolutely. I think most of those sentiments are echoed by all of us. Absolutely makes a lot of sense because, this year has been pretty hard on all of us being at home. So, I think one of the things that, of course, I've always been a big fan of your work. So I'm going to be tracking your stuff very closely. And I think folks listening in or watching this will also be interested, and I hope they take to software bill of materials and dependency analysis with dependency track. And those of you who are interested, both of these are open source projects. Feel free to contribute to that or the software component verification standard drive that Steve and team are part of at OWASP as well. With that, we come to the end of this podcast. Thank you so much for your time, Steve. I think it was an illuminating session, at least for me, and I think for a lot of people who are going to be watching this as well once it's out. Thanks so much.
Always a pleasure, Abhay.
Thanks.